Welcome back, everyone, to ABG Investor Days. My name is Henrik Hintze. I'm an equity research analyst here at ABG. With me now, I have the CEO of Freemelt, Daniel Gidlund, here to present the company. Please, Daniel, go ahead.
Thanks, Henrik. Okay, so Freemelt, we are a deep tech company and also a green tech company. And what we do is to develop and sell advanced 3D printers for metal applications. The company was founded 2017, and the company was founded by former Arcam employees. So Arcam was another successful Swedish 3D printing company. And currently we're around 40 employees. We did launch our first machine in 2019, so 2 years after the company was founded. This was maybe not the best timing because it was just prior to the pandemic, so it was a bit of a bumpy start. But I think despite that kind of bumpy start, it has been quite a successful journey so far. So year to date, we have sold 22 machines. We are working under the umbrella of something called powder bed fusion, so that's the technology. Here you have the energy sources is laser and electron beam, and we work with electron beam. I will come back later about the benefits on that as well. During the past 12 months, we have had net sales of 28 million, and we have an ambition to be a market leader. At this moment, GE is the market leader who made the acquisition by Arcam. But we would like to take over that market position by 2030, and at that time as well, we should have a business turnover of roughly 1 billion SEK. So what is 3D printing? So 3D printing in a nutshell, I mean, it's the opposite to metal cutting or machining of metals. Instead of having a big piece of metal that you machine down to the end application, like in this case, orthopedic implant, you actually put powder into the printer, and then layer by layer you build the application in one kind of process. You import a digital file, so a CAD drawing into the machine, and then it's by automatic then start to print. So it's really a true digital manufacturing as well. Other benefits with 3D printing is that you can also then build and design the product really after the specific kind of application. You can also, I think one of the key benefits as well, is that you can also put in different kind of material structures and properties really suitable for the application. Same kind of thing if I take this hip cup from an implant point of view. Here it's titanium, and you can really build it both, I mean, from a structure point of view, that is good to really get the bone ingrowth into the implant, but also to make it lighter, of course, if you put it into the body, and then strong. So that's, of course, also a key benefit. The other part is that you can also move your manufacturing footprints. Instead of having it in different parts of the process, from the metal cutting in one part of the world, and then you ship it around, you can actually put the manufacturing closer to the end user as well, which brings also, of course, a lot of benefits. The other part, an outcome of this as well, it's also really driving or enabling, I would say, a big part of the green industrial transformation that is happening as well. So it's really much better for the environment as well. So first, when it comes to waste reduction, so again, if you take the big piece of metal that you need to cut down to this small piece, I mean, you have a lot of waste on that piece. Again, if you take the powder and you build it exactly in the shape that you want to, you have pretty much no waste. And then you can also take the powder as well, and you can reuse the powder, and you can use it for the next build. The next part, as I touched already on, was more from a supply chain point of view. So it's of course time, but also you put out a lot of pollution as well if you ship around heavy materials around the world as well. So from that point of view, it's also better for the environment. And maybe the last point, which I think is also important to mention, if you take into the metal manufacturing industry, it's quite a heavy, noisy, dirty environment as well for people to work in. And here, if you go into a factory of printers or from an additive manufacturing point of view, it's absolutely noiseless. So it's a silence operation. It's clean. So I think here you can also attract new type of competence to the industry as well. There are different kind of technologies in 3D printing, and as I said, we are in the powder bed fusion, which, when it comes to the metal applications, represent, I would say, more than 60% of everything that is manufactured. The laser part is one of the energy sources. This has been in place for more than 20 years. We work with electron beam, which is another kind of niche, another kind of energy source. And the main difference, so at this moment, the focus in the industry is going from prototyping. So you have had a lot of prototype kind of focus in the past. Now we start to go into mass production. It has taken a lot of years to get to this. But here we definitely have a benefit with our technology, because an electron beam, for instance, you can move pretty much 4 kilometers per second, so an extremely high speed. The other part, which is important as well, if you're talking about material properties, is that you can also manufacture in high temperatures. So we have a vacuum chamber, which means that you can print in between 700 up to 1400 degrees Celsius. Which makes the properties in the product also much stronger and better than otherwise. So from that point of view, now we're really well positioned when we're stepping into the mass production opportunities. If we look into the opportunities then in metal printing, so here you can see the total addressable market. It's quite huge. Additive has been in place for 30 years, and if we zoom down on the adoption rate here, if we start from 2021, it was pretty much 2%, so 3 billion euro opportunity. This has been a double-digit growing business or industry for quite many years. It will continue, so it's a CAGR of 26% until 2026, and I think even beyond that as well. So there you see the opportunity at this moment of 8 billion euro. And this is, I think it's important to say as well, these are applications that are printed today. So then, of course, you have a huge untapped opportunity as well. If I take again the hip cup or the implants, only 4% of all the implants at this moment are printed. So it's just a huge organic, let's say, growth opportunity for these products as well. The 4 biggest, let's say, applications so far is in healthcare, which includes implants. You have also X-ray equipment as well, which is also a lot of components printed for. Then you have industrial, so here it's still a lot of prototyping and special kind of components. Automotive, very price sensitive market, high volumes. And then the last one is space, which is continue to grow as well. Freemelt, we focus on 3 materials. We have 4 focus areas. The first one is research. I think that was also one of the reasons why this company was founded, because it's a competence gap in the industry. More people need to be aware of the opportunities with additive manufacturing. Personally, I think I'm quite disappointed on the development during the 30 years so far, but it's mainly a competence gap. And this is why we try to target also the universities and the research institutes, really to get in the knowledge about additive. And of course, we would like to steer them towards electron beam powder bed fusion that we work with. So a design engineer really starts to think how to design the products from an additive point of view, and also how you structure the factory as well from an additive manufacturing point of view. So that's a key focus for us, and you can see here as well that AM Power estimate it will be roughly 700 machines sold by 2026 as well here. And we have a very good position at this stage. Then tungsten. So tungsten is, first of all, it's the material that would have with the highest melting point in the periodic system. So really to melt this product, you need to go up to more than 3,400 degrees, which means it's really difficult to machine and work with this kind of material. Why it has not really been focused on this before, but now what we have proved that you can pretty much get full density in the material, and suddenly it starts to open up on really a lot of new potential applications for this. Just to mention, a few. I mentioned X-ray equipment. So this material is really good for radiation perspective. So here we have seen already start of 3D printed products for X-ray. The other one is semiconductor. This is new, same kind of thing, very harsh kind of manufacturing environment where once again tungsten is very good. You have in defense. You have also then for fusion and also nuclear. So energy, I would say, is one of the key driving forces or demands for us when it comes to tungsten. Fusion might sound and be seen like very futuristic as well, but actually now there is more than 35 private initiatives around the world, and it's a huge focus. Also, if you go to US, to UK, France, etc., regarding fusion, and it's not that actually far away. So Commonwealth, to take one example, they have an ambition that by 2050, 20% of the world's energy should be produced by fusion energy. Really to get to that situation, of course, they need to still solve the technical challenges, but even a bigger challenge then is to produce those reactors. And then tungsten is a key component because we're talking millions of degrees in the chamber. And tungsten is, if you can also then print in cooling channels on the backside on the tungsten tiles, then that will also be crucial. So here, just to take the Commonwealth, it would require tens of thousands of printers just to solve Commonwealth need. If I move to titanium, I've showed this a couple of times now. This is the hip cup, same kind of thing. I think 3D printing it's really suitable that you can design products really to fit into your body in a good way. You have also aerospace, which the old Arcam, not old Arcam, but that Arcam focused a lot. Same kind of thing here. EPBF technology that we have is also highly suitable. So that's also an area that we focus on. Last, and I would say at least for us, least at this moment, is copper. So this is ultra pure copper. This is mainly for electromobility. It's mainly for connectivity. And here we talk about the pure copper. So to get the highest connectivity in the end. And to have here, it's must to have a vacuum chamber like we have as well. So that's also an area that we focus on. I would say defense is also popping up more and more in request of be able to print copper. These are the current customers that we have. So far, our key focus has been on the research, as I mentioned before. So the machine that we have in place, we have sold to prestige universities and institutes around the world. That I mentioned before plays a key role as well now to really get the transformation going faster. So their job, what they're doing, of course, is trying to identify new type of material properties, but also identify new kind of applications to industrialize as well. If I give you one example here that I think is a bit of a role model as well, in US there is a program called America Makes, and what that really, the purpose of that program is now that US is trying to take back a lot of the manufacturing industry that they outsourced in the 90s and 2000 from the low-cost countries and a lot from China. And to be able to compete with the low-cost countries, you need to be more innovative. So you need to have a different type of manufacturing because otherwise your cost will be too high. So America Makes is pretty much about to industrialize 3D printing. So Department of Defense, Department of Energy, and so forth, now has given the task to this program to industrialize 3D printing in US for the US industry. So we see a lot of focus. Defense, energy, semiconductor, all focus areas at this moment. The good thing also with these customers is that they have tested our product now as well for quite a few years. And now when we step into the industrial segment, we can also, of course, we have taken all their kind of feedback into consideration as well. So good, let's say, beta testing, if you call it like that, for quite a few years, because we use the same core technology for our industrial offering or machines as well. So the first one is Freemelt ONE. So this is really an open research machine. A very transactional business for us, not too much aftermarket and recurring revenue on that one. The next machine that we have commercialized or in the phase of putting into the market is eMELT, and we have a one build chamber machine. So this is for your application development. So first you develop your material process. You secure that the material properties are as you want to have them. Then you need to define this application, and then you need to start to mass produce, which is the third machine, the IM. So eMELT iD is for development, IM is for manufacturing or mass production. And what you see here is actually something unique. So again, I dwelled a bit about the poor development of 3D printing during the 30 years. I would say it hasn't happened too much from development. Most of the machines look the same, and the problem is here that the machines are designed that you have to work at the machine prior to the print. So you do all your preparations at the machine. What happens then? You block for production. Then after the print, you need to stand at the machine and you need to do all the post work there as well, which means you block the machine from production. So we have rethought, if that's English now, the whole kind of concept. So we have a modular build. We have modular build stations that are independent, which means that you have these are 4 per machine. So you have 4 others in a specific area for powder handling in your factory. You prepare them during the build here, and when these build units are done, then you pick them out and you swap in the new ones. So you do all the pre and post work in some other space of the factory. So this is totally unique. The other part that is also a big hustle is that, we talk extreme temperatures here, and in all the other machines with big build chambers, it takes 6, 8, maybe 24 hours to cool it down before you can take it out. So the machine just standing there, not able to produce. And here we have an active cooling during the build, which means that within less than 30 minutes you can take them out. So really the key here is to increase the availability for productivity. Over the years now, we, of course, have worked, not of course, but we took the decision to work closely with industrial partners to really make sure that we also then develop a concept and a machine that will also bring down the total cost of ownership for specific applications that we target. And this is one example. This is the one build module that compares to all the other pairs in the industry. And here, that one, we are at least 30% more efficient than the closest competitor as well. And then, of course, if you add up to the 4 build chamber, of course, the efficiency is even higher. So we have a fairly good confidence now when we go to market with this. If we look into where we are at the moment, so we just now in the commercialization phase. So we also as a company, we're moving a lot from technology focus into a commercial, let's say, focus. And from the research, we will continue to focus on research and really get more machines out there as well. But the key thing here now is the industrial segment for us, where we, from Q2 next year, can deliver machines to our customers. And the industrial segment as well, it will be much more a performance type of pricing and business models rather than the transactional business models that we have for the research machines. So much more focus on services and, of course, the recurring revenue from the aftermarket side as well. So if I would just wrap up this, I mean, at this moment, the industry is just at the tipping point from prototype focus to mass production. Technology-wise, we have a really suitable technology to take a good position here because it's really about productivity. This will be an important part for us as a company to take the next step towards also profitability as well. So thank you.
Thanks a lot for that, Daniel. Let's move on to some questions. So you mentioned that sales so far of the Freemelt ONE have mainly been one-time transactions where you just sell a machine for X amount of crowns. Could you talk a bit about how your business model is going to develop now, partly with regards to Freemelt ONE, but also looking at eMELT?
Yeah, sure. I think when it comes to Freemelt ONE, as I said, it's really a transaction. You sell one machine, and then that's pretty much it. Not too much of aftermarket. Here we even would like to go to even more universities, get it out even more. So I think we will maybe change the business model, maybe more as from a leasing perspective, more maybe renting, or even get a lighter kind of product with lower price as well. But on the industrial side, that machine, then we will have more of a performance-based kind of pricing. So really try to gain, let's say, trust and confidence at customers that we can also deliver the total value that the customer expect to get out from the machine. So I would say we will go in two different kind of directions from business model perspective. And maybe in the future, I think maybe we don't sell the machine, we sell more commitment on volumes that the customer can print for certain kind of applications.
All right, very interesting. Now, eMELT is almost getting ready for its first sale, beginning of next year, hopefully. Could you talk a bit about what we can expect in 2024? It's very hard for us to know, from our point of view, what's going to happen, how fast will you be able to get these products to customers, what will take longer versus what can happen in 2024?
Sure. I think it was at least a wise decision that we started to work closely by two industrial partners. One of those partnerships, I mean, we also announced more of a firm commercial agreement with when it comes to tungsten applications recently in October. But currently, I mean, we have a beta machine up and running in Gothenburg, where we have our head office. And we do testing now and trying to also get the processes in place for titanium, tungsten, and copper. And then in Q1 next year, we should have completed also the application process development as well. So from Q2, then we, of course, will try to really go broad and then really address certain kind of applications. Here, I would say there is a couple of opportunities. You have existing 3D printing companies. If you take laser, for instance, so if you have already started to print with laser, you have taken the step from the traditional manufacturing into additive. Here, we can, by productivity, go and offer a better solution. So that's, of course, an opportunity. You have also existing, I mentioned Arcam, existing PBF solutions out there as well. Same kind of thing, different kind of concept. We can drive productivity as well. And then of course, I mean, you have the untapped opportunity with traditional manufacturing, which is an education that is needed as well. So it will take some time before really the hockey stick, I think, would come. So 2024, we hope to get a few more contracts. 2025, I think then we'll start to see some sort of volume increase and hopefully really to take off from there.
Yeah, good. And when that volume hopefully comes, then how are you going to manage to scale production of these machines? What do you think will be the main bottlenecks there?
I mean, we're trying to be a bit proactive here as well. So during this year, we have actually prepared for outsource as much as possible. So at least for sub-assemblies, really to try to find partners as well that has a much more agile setup than we. Our focus should be more on the commercial side. And I think also the components that we have in the machine as well, it's a good and solid supply chain as well. So at this moment, I don't see any kind of major risks. And of course, we haven't signed up yet for the final parties, but that's what we are in the final negotiations on at this moment.
All right, that's very interesting. Thank you very much, Daniel. That's all we have time for, and thank you all for listening.